Hi, my name is Bryn Lewis, and I've been a Microsoft MVP since 2015. I started as a Windows hardware dev with Windows 10 IoT Core, and then after realizing the writing was on the wall, I moved sideways to Azure and IoT. There are two IoT MVPs in Australia and New Zealand, me and David Jones in Melbourne. I've been working in the IoT world for an embarrassing number of years. I started back when it was originally called SCADA. My first process control project was managing a switch yard where failures were very spectacular and very expensive. One of my co-workers blew up a power factor correction bank at a sawmill, which was $250,000. I got interested in Myriota when I did some work on a project where we had no cellular or LoRaWAN coverage, so satellite connectivity looked like the only option. After some discussions with a friend, we also figured it was useful for global applications like tracking shipping containers or things like that, where you needed a consistent billing model with some roaming SIMs that there are issues about if you spend more than a month in a country which is not your own and so forth. It started with a customer wanting a satellite IoT project built. They were planning on using Azure Service Bus, and it was a very bespoke implementation for their application. The project was deferred, so I decided to build a version and open source it, which used the Microsoft IoT platform. As a side note, there are some people on the call from Myriota, so if you have any questions, just chuck them in the chat or ask at the end. So this is the device manager for the Myriota website. The devices don't consume a lot of power. They wake up to transmit and receive only when a satellite is overhead. The module sends any queued uplink messages and listens for any downlink messages and then doses off. You'd expect that the current median latency is roughly 3 to 4 hours. It depends a lot on how much sky your modem can see, things like that. The messages are 20 bytes each. That's 160 bits. It's important to optimize the format of your payload to reduce the size of the payload. You might want to consider using an industry standard like LPP, the low power protocol. You can do 50 messages a day with a total of a K per day. The messages aren't confirmed, but on uplink from a device on my front fence, I get roughly 95% delivery. And on the downlink, I get roughly 45. So it works pretty well. If you want to give it a go, Daniel, who's on the call here somewhere, give him a call. You can buy a Myriota Dev Kit. They're 300 bucks Oz. It has a tracker, one of those, which you power with a couple of lithium AAs, a dongle, which is a satellite network simulator, which is pretty cool, and a couple of little Myriota modules are tucked underneath, or actually they're next to the power cable. It includes 3 months of free data and a chat with an applications engineer to discuss what your problem is. You also get access to some SDKs for writing software for the module. It's got an onboard microcontroller, which you can download code onto, and some cloud SDKs or cloud APIs for sending and receiving messages, asking for lists of messages and stuff like that. The device developer kit is really for embedded engineers. It requires you to be running a Linux box and you're writing C and C++ code, or C++ code. Though I'm looking at writing a .NET Nano framework library, so you can run .NET on a small device like an ESP32, because one of the samples emulates a modem, which uses Haze AT commands. Data plans start at roughly $1 a month, depending on how many devices you've got, how much love you give Myriota, so forth. That's the module. It's basically about the size of half the size of the last knuckle of my thumb. It's got a small form factor. It's pretty lightweight and comes pre-programmed with a bootloader. So once that's soldered onto the board, flow solder on the board or whatever, you can basically plug a cable in, flash it with your software and start debugging. If you've got a larger application or something a bit more complex you want to test, I've got a Sense&Locate cable tied to my front fence. It's 299 Australian. It's got an IP65 enclosure, so it's quite weather resistant. And for this part of the world, it's made with UV resistant plastics, so it won't fall apart if you leave it out in the sun. It's got a 4 to 20 milliamp sensor interface, but you can also hitch other sensor options to it. You might want to do RS485 or I2C, something like that. So for those of you who get really serious, RF is hard. It's really hard. I worked in a mobile radio company for 5 years and it looked hard. So if you want to try something a bit different, you can buy the mouse antenna. They're 130 bucks, and it's the same thing. It's got a rugged enclosure. It won't fall apart if you leave it in the sun, and it's got different length cables that you can put on the roof of your truck and put the unit inside. So after a few iterations, this is what I ended up with, and I'm going to run through it in a bit more detail. The Myriota Azure IoT Connector takes care of all of this specialness of satellite comms, and it makes it really easy to use with, easier to use with Azure IoT Hubs and Azure IoT Central. If any of you have seen the system message about Azure IoT Central being retired, that was a mistake. Go and look at the Microsoft site. It accidentally sneaked out. Messages are not confirmed, so your application needs to manage this. The uplink messages can take hours, depends a lot on your coverage, and downlink messages can take longer. Myriota suggests that if after 36 hours, nothing has happened, you should try again, which is pretty good. Originally, this project was built to connect into Azure IoT Central, but it's also been adapted to work with Azure IoT Hubs, and it also integrates into all of the standard plumbing so that you can run logic apps, you can integrate with event hubs and run data out into Power BI. Basically, you can hang stuff out of the back end of your Azure IoT Hub and magic will happen. When I started off with the Myriota gear, they published an open API description, which works pretty well. So I sat down with NSWAG by Rico Sutter and generated a client for it. I had a bit of a pain trying to send messages. So, and as I only needed a couple of the methods, getting a list of modules and sending a downlink message, I binned the open API and NSWAG approach, went to RestSharp. And after sorting out a couple of resource leaks, RestSharp has worked really well, and the code actually got a bit simpler. I really like RestSharp now. It takes care of all of the packet formatting and serialization and deserialization pretty well. So connecting to an Azure IoT Hub, Azure IoT Central, you've got some protocol choices. MQTT is the hot thing, message queue, telemetry transport. Microsoft people, IoT people seem to jam it into every second, third sentence. It's got some downsides. Can't use it across things like NB-IoT because it's pretty hard on your battery. You've got TCP/IP keep alives, you've got Nagel coalescing, and on top of that, you've got MQTT keep alives, blah, 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 blah. Suddenly your battery, which is supposed to last 5 years, lasts months. You've got HTTPS connectivity into the Azure IoT Hub. It establishes a temporary connection for each device. There's no push from the cloud out to the device, and you can only poll every 25 minutes, which isn't great, but you can work with that. I use AMQP, which is the Advanced Message Queuing Protocol. It originally spun out of the high-speed trading community in the US. Great thing about it is you can multiplex about 990 odd AMQP connections across a single TCP/IP connection. So if you have a Azure SKU, which limits the number of outbound connections, it won't explode in your face. The other thing with Azure IoT Hubs and Azure IoT Central is you need to have a connection open before you send a message, can send a message to a device. It's not like an SMS where you can just send something. So on startup, the Azure function has a startup task which calls the Myriota Device List API and starts to populate a memory cache with open connections. An uplink message might come from the Myriota infrastructure as you're loading the cache, but Lazy Cache has a whole bunch of plumbing which takes care of that and takes care of the concurrency issues and the handling of exceptions and stuff like that. It basically uses the iDistributed cache interface. So it's what's called a read through and write through cache, rather than a cache aside, which is the usual model. The Myriota Cloud API, I've configured it to call a webhook. I usually, and for other low-power wireless systems, I create a lightweight web API endpoint. It doesn't really have much. It just receives the message and shoves it into Azure queue. Because there's not a lot of code, I'm less likely to have introduced bugs. This is being recorded, but I might as well go for gold. Internally, we refer to these as a craplet. It's small and it doesn't really do shit. This is so I can start and stop and redeploy the Azure function, which does the bulk of the work without losing any messages. And if I get a mangled message from the front end, it's automatically moved off to a poison queue where you can inspect them and resubmit them or delete them. This is what a sample uplink message looks like. The bit that you care about is the value. The payload only contains so far one packet, and then you've got the terminal ID, the timestamp it arrived, and then an encoded representation of the 20-byte payload. There's also some information about the security used and the signature, so you can stop someone impersonating the Myriota plumbing. So that's not a lot of use to anyone beyond CISOs like me. So what we've got is some payload formatters. This idea came out of some work I was doing with LoRaWAN networks, the Things Network and ChipStack, and I also wrote some LoRa code. So what happens is we have a payload formatter, and there are separate ones for the uplink and downlink. The uplink one returns a gobbled JSON and takes the 20-byte payload, and then it uses some C# code to translate it to something useful. The downlink formatter takes a gob of JSON and then formats it into a series of bytes to be sent to a device. I use CS script to compile the code in the payload transformer, and this gets rid of the overhead because there's some overhead getting the C# payload formatter out of the Azure storage container and compile it. So the binaries are cached for reuse. The uplink formatters have the standardized interface, so you can just bash away and build more and more of them. And I've got a couple of simple command line applications which let you test your uplink and downlink formatters with some data. So this is Azure Storage Explorer. I've got a bunch of payload formatters for formatting data coming from devices. I've also got some test cases there. I've got the Homer Simpson lights go on, lights go off, and we'll talk about that in a bit. You can modify the formatters, upload them, bounce the function, and then it will reload them. Sometime in the future, I will make it so that they're detected and automatically reloaded. There are uplink and downlink formatters, and you can configure a default formatter for application for each uplink and downlink. And then you can use module attributes. The Myriota devices have a concept of an attribute. So in the attributes, you can specify a specific uplink and downlink formatter to use. So if you have your own custom formats for a device or versioning considerations. To make things easier, I usually copy the C++ structure of the payload into the top of my C# formatter. So this is the tracker device payload format. So you need to adjust the latitude and longitude and convert the time from Unix time back to UTC time, or time that normal humans can understand. So this piece of code is a uplink formatter. it gets loaded from storage, compiled into binaries, and then called every time a message is received from the Myriota back office. This sample formatter discards any empty messages, because you might get the odd one. It adjusts the latitude and longitude values, and then it maps the values that it's received into a gob of JSON, which is returned to the caller. You can see I've fudged the Unix epoch and added the seconds to it. And then the important thing is, if you're doing Azure IoT Central, is the IoT Hub creation time at UTC. That allows you to timestamp a message for when it arrived at the edge of your infrastructure rather than at Azure IoT Central, which is important. So after that payload formatter is applied, you end up with a payload which looks like that. This is an Azure IoT Central compatible payload, but you can generate them in whatever JSON format you want. If you're really determined, I think you could most probably do them as text and maybe even as binary. I've not tried that. So in the payload, you can see the time of the fix, the time it was received by the web API, the time it was processed by the Azure function, and a whole bunch of other stuff, padding. And then I also include an ID code, which is added to the message when it hits the web API, so that I can track the progress of a message across all the different bits of plumbing. I've also included some debugging type information, and in the logging, I have a unique identifier for every message, so I can hunt down bugs, spontaneous features. If you're using Azure IoT Central, you configure templates, and these specify the format of the messages received from the device, or commands to be sent to the device. The payload of the uplink messages, the 20 bytes, has got to be reformatted to suit the specific Azure IoT Central format. There's a format which is documented, and I now know more about than I really want to. Sort of things is the Azure IoT Central position format has quite a specific design, and it's actually case sensitive, which is really painful for, and the case is not what you would expect for the JSON payload. That tripped me up a bit. This is the uplink, and you'll notice I'm a real developer because I've got dark mode. This is the uplink telemetry from a tracker, and I've unpacked it and converted it to IoT Central format. You can see that every message has got a sequence number, and in this case, the sequence number 232 is missing. You just have to compensate for that in your application. It's not really a problem. So this is, if you do your templates right, this is the sort of user interface you can get, and we'll look at some maps in a bit. So this is the format for the, oh, sorry, wrong way. If you're going to use in a plain Azure IoT Hub, I use Azure IoT Hub Explorer. And this is a uplink message received from a device which has had a payload formatter applied to it based on either the default payload formatter or name of the payload formatter configured in the Myriota device attributes. So it's reformatted the payload, it's got the device location, and it's added a bunch of metadata about when the message arrived and so forth. So that works really well, and I can stream that stuff up to other applications using Azure Events. If you want to send commands down, in the Azure IoT Central world, you've got these templates and you specify the commands sent to the devices. Each command has a method name, which is an attribute of the payload, and it's used to determine which formatter to use. There are 3 types of command. There's one which has got no payload. Lights go on, lights go off. The JSON payload for the command message is retrieved from the configuration. The thing that tripped me up initially is the payload is actually not empty. It just contains an @ symbol of all things. And then we've got a single value payload. It's like set the speed to minimum, set the temperature to this. And then there's multi-value payloads where you might set the minimum and maximum temperature range and it arrives in a gob of JSON. And the JSON payloads generated from this are processed by the payload formatter, which is configured on our side, on my side. So there's a lot of configuration. If you look down to the left, bottom left, you'll see there's lights go on, lights go off formatter, which is lights go on, off, lights go on, lights go off on.cs. So if someone presses the off button, light off button, it generates a gobble JSON with light false. If they press the on button, it's same payload formatter, but light's true. If it's a fan speed one, which is a single value, it calls the fanspeed.cs payload formatter. It also integrates with the device provisioning service, and it's got configuration settings so you can do your app insights and configure it for different types of applications. It'll do an Azure IoT Hub with device connection strings, an Azure IoT Hub with DPS, and an Azure IoT Central with DPS. So this is what, if you press the fan speed button with medium speed, a gob of JSON will arrive, and it will look like this. It'll be fan speed 2. It's sitting in the debugger because it's the best way I can find to explain it. Then the payload formatter will get called. And this is the payload formatter. It grabs the fan speed value out of the JSON, then builds a packet. The first packet is 1, which says first value of the packet is 1, which says what sort of packet it is, and then it chucks in the value. That then gets converted by the payload. You see on the line above, payload formatter.evaluate. That then converts it to a couple of bytes. Those bytes are encoded. And then if you scroll down, if you look at the bottom, about 2 lines from the bottom, it's got Myriota Module API send a sync. So that sends the message out via the Myriota Cloud API, and then link. So this is doing the same thing with only an Azure IoT Hub, and I'm using Azure IoT Explorer. I'm typing in a bit of JSON, and then I press go. It uses an Azure Direct method, which is a synchronous call. I would like to be able to make that an asynchronous call because it fits better with the model. So we'll see how that goes. If the message is missing, it's rejected. But the odd thing I've found is a message, you can't make an empty message from this user interface. Because if you leave it blank, you actually get two sets of quotes, a pair of quotes. And this payload doesn't have to be JSON. You can actually write a payload format. I think you could write a payload formatter which took text and sent it. I just didn't try it. So this is the architecture. Officially, it's known as a cloud-based identity translation gateway, which connects Myriota's back office to Azure IoT Hubs and Azure IoT Central. That's its incredibly long, mouthful name. I started off with a big deck of slides and I've chopped them out. So then you can bolt onto the back of that event processing filters. On the right-hand side, you can see that I load stuff from the storage blob, I load it into a cache, and then I pull out the receive payload and transmit payload formatters on demand. I then run a cache of device clients inside my Azure function. You've got to check always on so that the function isn't shutting down when it's idling, because then the problem is when it wakes up, it'll go back to the Myriota API and download all of its modules. And I hazard a guess, the Myriota people might not like that if you're doing it continuously. With the device provisioning service, you can set up DTDL v2, device twin definition language version 2 IDs, so that when a new device hits the edge of the infrastructure with Azure IoT Central or an Azure IoT Hub, it will be provisioned, and then with a DTDL v2 ID, it will then be assigned. So you can, if you're using Azure IoT Hub, you can enter the device provisioning service. You could take a device out into the field or configure it in the Myriota Cloud, turn it on, and sometime afterwards it would actually automatically provision itself. And then if you've got the DTDL2 v2 ID configured for the application or for the device and the device attributes, it would then assign it. So someone could turn a device on, it'd provision itself, assign itself, and then you get that tracker command and telemetry displayed working straight out of the box. So any Q&A? I think I've gone way out of time. Can't hear anyone.
Room mic, so that hopefully you can be heard. Any questions from the room? John.
I've got a question about the payload formatter. So could I use a C# struct and then use the memory layout of that struct to serialize the payload to binary instead of sort of declaring a byte array and assigning the values myself?
You could most probably do that. I haven't tried it. I tend to use the bit converter. So I can say, hey, convert this floating point number to 4 bytes and insert it in here. Personally, I think it's just a matter of taste. Yeah. Some people do, and some people don't. If anyone's interested, I've got another couple of slides. Maybe some more questions after those. As an IoT developer, this is a common problem. Often when you start up a GPS unit and it's connected to a device, if it uplinks a position before it gets a fix, and I have been stung by this many times, so please don't be that developer, you get a fix from 00, which is somewhere off the coast of Gabon. It really messes with the scalings of your map, distances covered, and an average speed. So it can be a problem, though. That's it there. Basically, Gulf of Guinea, 00. It has a mythology associated with it. Some people went and put a boy there. And this mythology is, any of you, Thomas the Tank Engine with Sodor, the mythical island? People have written stories about it, and there's this mythical island at 00. So some people have way more time, hence than I do. So some more Q&A if anyone's got any questions.
I have one question myself, actually. You mentioned it's important to have the timestamps of when it hits the edge separate from the timestamps of when it's received by the central hub. What's the reason behind that? Is it just debugging?
Azure IoT Central sorts stuff for the lists based on the timestamp of the message, and with quite a lot of radio backhauls, the messages might arrive out of order. So if you want the messages to arrive, say, in the order of the fix, the GPS time and date, you have to set that IoT Central, whatever it is. Otherwise, they will be displayed in the order that they arrived, and that can be a problem. Like on a mesh network, you can get substantial misordering of packets as they make their way across the mesh network. So it's just a presentation thing. It's to make the messages in order based on the time on the device rather than the time they hit the cloud.
That makes sense. Thank you. Any other questions from the floor? Nope.
Cool. Ben, are you out there? Oh, sorry, Daniel, are you out? Do you want to say a few words? Sorry, Daniel.
No, I wasn't particularly prepared to say any. I was happy to join in with any questions that came off the floor. I think Bryn gave a very sound representation of Myriota at the beginning, and there was at no point was I sat there scratching my head or questioning anything and felt necessary to jump in. So that's great. We're obviously very excited about some of the work that Bryn's been doing, and looking forward to seeing what opportunities we can partner up on with him moving forward. But again, we're also keen to find new applications and ventures. So if there's anyone who is on the call currently or joins us later on who wants to learn more about Myriota, then we'd welcome you reaching out to us.
And you're in Adelaide too.
We are in Adelaide, that is correct. Yeah, we're based in Lot 14, the old Royal Adelaide Hospital. Now very much a bit of a space and tech hub. Yeah, very, very blessed with the office there. And a wonderful coffee shop just at the front, Bryn, which the next time you're in Adelaide, we'll host you at.
I was actually drinking coffee before this meeting and I realized how old it was. This mug is for Windows Advanced Server 2000. I got that when I was working at Microsoft.
Two young kids in my house, the glass doesn't last that long.
Yeah, I had 4. Yeah, so thank you very much for your time. If anyone has any questions, I'm at KiwiBryn on X, Twitter. I'm on LinkedIn, but my page is incredibly blank. I've just been a dirty, filthy contractor for a decade and done all sorts of things from online gambling to AML and CFT. It's a smart ag. Currently, I'm working on a smart ag project which uses machine learning to count cows in a yard. So I've got jets and nanos and stuff like that. And I'm also, if any of you have heard of the Imagine Cup, there are 20 global semi-finalists, and I'm mentoring a team in that based out of London. So we have difficulty scheduling meetings currently because there's me in New Zealand, the team in London, and their cloud advocate is based in Brazil. So it's difficult. Has anyone else got any further questions?
No further questions from the room. Thank you so much for coming and talking about Myriota, Bryn. It's super exciting to see some of the, for me at least, the architectures that you have to put around to actually get these IoT things all communicating correctly and in a way that you can actually glean some data out of. So yeah. Thank you so much for coming along and giving a talk.
Thank you. I will drop offline. If you want to ask me questions, email me. I'm quite happy to answer questions. And if you're in Christchurch, you can pay for it with coffees.